Hey, welcome to today's video where we'll be talking about the history of the atomic model. So, first of all, I just want to cover the first model I want to cover here is our current atomic model. So, as of now, today in 2022, atoms are defined as the simplest unit of matter which still retains the object's original chemical properties. For example, an atom of carbon, which we will denote with a C, carbon is the simplest, smallest unit of matter that still has the same physical and chemical properties as carbon, such as it's not a very strong conductor, it's a decent conductor. So if you were to take a carbon atom, you would see the same idea. This carbon atom is not the best conductor, but it's a decent conductor. Our current model of the atom is known as the Bohr model, or rather the Bohr model is a relatively simplified version of the actual model, but the basics are pretty much the same. The Bohr model depicts a nucleus in the center over here and this nucleus has positive charges called protons and neutral charges called neutrons, which are surrounded by a bunch of electrons, negatively charged electrons, that are orbiting this nucleus. Now, in reality, like I said, the Bohr model is just a simplified version of the actual atom. In reality, an atom is much more complicated in the sense that these electrons don't follow strict orbits. They're actually in a big area, in a big region surrounding the nucleus called the electron cloud, and these electrons are actually buzzing and fizzing around everywhere within this cloud. And it's very hard to predict where they are at exactly what moment, but that's generally how they're depicted. In fact, there's another interpretation that considers electrons as having their own wave functions, which is the technicality of how we actually got these whole orbitals and everything through the Schrodinger equation, but that discussion is for another day. For now, all you need to know is that in the center we have a nucleus with positively charged protons, neutrally charged neutrons, and on the outside we have some electrons that are moving around in random orbits around the nucleus. Now, I just want to cover a few important properties of these three particles, the proton, the neutron, and the electron. And a quick note, these are all called subatomic particles because they are within atoms, subatomic. All right, let's begin with the protons, which I'll do here in red to match the diagram. Protons are these red atoms you see. They're heavy and positively charged particles, and they're found in the nucleus, just like we just said. The number of protons actually determines the atomic number of an atom, which we denote by Z. Not exactly sure why they chose Z for this, but it is what it is, and this is what's most commonly used to denote atomic number. So for example, the atomic number of carbon is 6 because carbon is the sixth element. So we would write Z equals 6 for carbon. Now we have the neutron. Neutrons are also, well, I'll do this one in green. Neutrons are these green neutral particles you see here. Neutrons are heavy, similar in mass to the proton, and are actually uncharged particles. They're neutral, and they're found in the nucleus of the atom, like we just mentioned. The total number of protons and neutrons in an atom is called its mass number, which we will denote using A. So for carbon, it has 6 protons and 6 neutrons, which means that A is going to be 6 plus 6, which is 12. And the units for A is atomic mass units. Atoms with the same number of protons, so same atomic number, but different number of neutrons, or different mass numbers, are known as isotopes. All right. And continue on finally to the electron, which I will use blue for. The electrons are those negatively charged particles out here. Electrons are very special in the sense that they are almost 1,800 times lighter than protons and neutrons. Yet, they're negatively charged particles. They're found in the electron cloud of the atom, which is the region surrounding the nucleus where the electrons could be at any random point in time. And the number of electrons in a neutral atom is the same as the number of protons, because the charges need to balance out for the atom to be neutral. If this is not the case, if there's a difference in the number, then we call that atom an ion. And we'll be talking more about ions and isotopes in the coming videos because they play a very important role, especially in chemistry and in bonding when we're forming compounds. So don't be surprised if you see the concept of ion come up again. But where does the concept of ion come from? Isotopes come from? It all comes from our current atomic model, which in a sense has a positively charged nucleus surrounded by negatively charged electrons. So that's it for the current atomic model. Thanks for watching and hope this video helped.